Hey there. So, day 16. Interesting, right? So, the good news is that that solution I had eventually finished and gave me the right answer, right? So it worked, um, which is good. The bad news is that when I got to part two, uh, it didn't work, and it's not so much that it didn't work, but it was too slow, right? And try as I might. Um, so like I tried modifying it for the elephants, right? And basically the idea behind part two was that now you have two guys who can go around and do stuff. And so the way that I dealt with that was I said, now my state is going to be my location and the elephant's location, my current path and the elephant's current path, and then still sort of go through and uh, basically work the same way with the problem that um, that I'd pick his stuff and my stuff, and that didn't work. It just ran forever and forever and forever. So then, thank you to commenter Karsten, who left me a comment and said one optimization would be to consider and minimize the path lengths between valves with flow bigger than zero and move only between those. You prune a lot of intermediate states, and you don't need the backtracking guard in this case. Um, so I thought about that and tried to make it work, and spent a long time trying to get it to work and uh, debugging it and whatnot. And eventually I did get it to work. So I'll just walk you through that. Um, so I called this the O network, which is the optimized network. Um, and it has the valves again, look up my name. And now we have these distances, which is given, valve A and valve B, how many steps does it take me to get from one to the other? Um, and then what are the names? And so this is super inefficient. Like nothing here is like done thoughtfully or efficiently. It was tinkering until it worked. So I added this post-init thing, which is neat, that you just pass in, let's say the valves. It gives you your lookups. It computes distances. Then it filters down to only valves that have positive flow because we don't care about the rest, right? And to compute the distances, it just does your standard breadth first search, where for each starting point, I run a BFS until I've seen everything, and I write down the distances. And then again, I prune down the distances where um, I don't care how far it is to something that has a flow of zero because I'm never actually going to go there. Okay. And so again, I have this best possible, which is, an overestimate of how good I can do so that when I get past that, I know I'm done, right? And there's sort of two things I did. One is that now instead of just looking at me, I looked at me and the elephant, so that I have to pop off twice when I can. And the other thing I did, which was because it was still too slow, is I said, you know what, like, let's say I behave optimally at every step, I'm going to have to move somewhere and then open something, which is going to take at least 2 time steps. So I'm going to subtract off 2 remaining time steps, and that gave me a tighter, best possible estimates. Um, and so then what did I do? Same kind of same core logic, right? If released is bigger than best, best is released. Um, and if everything's open, there's nothing to do, so just keep going. And now what I did is I said, and I'm tracking, so if you go back here, I'm tracking my time and the elephant's time, right? Because now that I'm thinking about distances, right, I could move from A to B and it would take me 5. If I do that, then that's going to set my clock forward 5 steps. So now me and the elephant have different times, so I have to track that. And so what do? I say, when I pull a state off of that priority queue, I'm going to look at whoever has the earliest time. And if the elephant and I both have the same times, then I'll let us both take a step. And so, if my time is less than the elephant's time and we haven't run out of steps yet, steps remaining. And now the way I've reframed the problem is that basically my only option is to move somewhere that has a flow and is not open and open it, right? So um, what I do is I say the tunnels are the places I have a distance to, which is the ones that have non-zero flow, take away ones that are already open because I don't need to go there. I have time to move, and then if I move there and open one, um, the added flow will be steps remaining minus time to move minus one because time to move there, take away one to open it, and then what's left is how many times it will flow. And I need to, you don't want to know how many times I got this logic wrong. It was a lot of times. I spent hours like getting this to work. Um, and then I have a new release, I have a new open, I have a new negative best possible, and then I push that onto the queue. And then, also, if the elephant's time is earlier, um, then I basically do the same thing for the elephant and run it that way. And it turns out that it works, and this way is actually really fast. But the logic is intricate and lends itself to easy off by one errors and is a pain. And it took me a long time to get it right, and it sucked. So I hate this problem, but I'm especially grateful to uh, Karsten for offering me that hint because otherwise I don't think I would have ever gotten there because what I was doing before that hint was not working. So this is working. I have it, and now let me take a break, and then I'll try day 17. Hopefully, day 17 won't be as bad. Anyway, thank you.